next unit, we are going to be talking about using the properties of parallelograms. That's the first section. So all the things that make parallelograms special and how to solve for different things when you're given a parallelogram. So we're going to start with the properties of parallelograms, or actually here is the parallelogram definition at the top. A parallelogram is a quadrilateral with two sets of parallel sides. That's the definition. So that is a property of the parallelograms, even though it's not listed. That is the technical definition of it, so they don't list that. So in a parallelogram, if this on the right is a parallelogram, then these two opposite sides will be parallel, and then this will be a second set, and if they're ever marking both sets, they'll use one arrow on one set and double arrows on the other set. So that's the first thing about parallelograms, the definition. The properties of them: opposite sides are congruent, because we already see that they're parallel from the previous statement. So opposite sides of parallelograms are congruent. I'm going to put the congruent markings on them. Remember that the parallel markings are not congruent markings. These little tick marks are congruent markings. Opposite angles are congruent. So this whole angle at A and this whole angle at C, and then the whole angle here at D and at B. Consecutive angles are supplementary. So like angle here at D, this whole angle and the whole angle at A, they will add 280 degrees. What supplementary means. And that's because the lines are parallel, and these would be consecutive interior angles or same side interior angles based on our parallel lines, and so they are supplementary. And then the last thing is that the diagonals bisect each other. And that means that, and I've already used 1 mark and 2 marks, so I'm going to need to use 3 and 4 markings. So this diagonal cuts, and they each cut each other. They're not necessarily, all 4 pieces are not necessarily congruent, but each one where they intersect breaks each diagonal exactly in half. So we're also going to look at some sample problems here. Find the measure of the indicated angle in the parallelogram. So we're finding B. So this is the one we want. We have this, that A is 64. These are consecutive angles, and they will add to 180. So if I take 180 and subtract 64, that would give me 116 degrees for this one. There's 180 minus 64. And then here we want angle M. These are opposite angles, and in a parallelogram, opposite angles are congruent. So this angle is the same as K, which is 96 degrees. Here is some samples using this one here. Number 3 uses the sides. And remember, at the top of the page, one of the first things we wrote down is that in a parallelogram, opposite sides are congruent. So these two sides are congruent, and these two sides are congruent. So I know that x plus 2, I can set that equal to 4. And I can solve for x by subtracting 2 and get that x is 2. And then to get y, that's the other set of sides. Y minus 5 equals 12, so I can add 5 to both sides to get y alone and see that y is 17. For number 4, I've got this angle is marked and this one is marked, and those are opposite angles, so I know that those are equal to each other. So I can set them equal to each other. And then I can add 60 to both sides to solve for y. So y would be 116 degrees, or 116. I mean, it is in the angle there, but it's not just the angle. So I'm just going to say 116 is y. You would plug that in and subtract 60 to get the angle itself. And then the other thing here is the side. And these are opposite sides, so they are congruent. So you can say that 3x plus 4 equals 16. Subtract 4. 3x will equal 12. Divide by 3 to get x alone. And x is 4. So there's that side, or that x value. All right, so this is just solving for some angles and some side measurements, knowing our properties of parallelograms.